Hey crafters, welcome back to Control Crafting. I am Amal and in today's video we are going to dive deep into Armstrong numbers. So we'll cover everything from coding an Armstrong number program, understanding the core logic behind it, to analyzing the time complexity. Moreover, there is a tip at the end of the video, so make sure you stick around it. Now let's discuss what's an Armstrong number is. So an Armstrong number is also known as Narcissus number. So let's see why we call it. Suppose we take an example 153. By the definition of Armstrong, we have a number that is equal to the sum of its digit. Okay, the sum of its digits. So we have to take the digits out. That is equal to the sum of its digit, each raised to the power of the number of digits. Each raised to the power of the number of digit. The number of digit is here 3, or you can basically say the length of this number is 3. So we have to make sure that our definition is satisfied here. That is a number that is equal to the sum of its digit. We have to find the sum of digit, each raised to the power of the number of digits. So if 1 cube plus 5 cube plus 3 cube, that is equal to 1 plus 125 plus 27. If this is equal to 153, then 153 is an Armstrong number. Okay, let's take another example. We have an example, say 1634. So 1634 will be equal to 1 to the power 4 plus 6 to the power 4 plus 3 to the power 4 plus 4 to the power 4. If all these these value is equal to 1634, then 1634 is an Armstrong number. So what's not an Armstrong number? Let's take an example 111. So 1 to the power 3 plus 1 to the power 3 plus 1 to the power 3 is equal to 3, but 3 is not equal to 11, triple one. So that's not an Armstrong number. Why we have raised to the power 4 in the 164? Because number of digits is 4 here. Why we raised to the power 3? Because the number of digit is 3 here. That's why we are raising to a specific number of powers, that is the number of digits. Now let's have a a simple approach while we have a problem. So if I know the definition of Armstrong, that is we discussed, and I have a number 153, then how am I going to approach this problem? Like how am I going to do that? So first of all, my first thing is to find the number of digits. This is my first step. So that can be done in two ways. We will discuss those ways later. The second thing is what I have to do after finding the number of digits. I have to take out each digit. Okay. My third step will be I have number of digits. So here we have 3 digits. I'll take out each digit. And the next step is like I have to find the, as per the definition, each raised to the power of the number of the digits. So since we have 3 here, each digit should be raised to the power of the number of digits, or each raised to the power of the length of that number. And then we have to do the sum. So the next step is power of each digit. The fourth step is sum. The fifth step is check. Like, okay, we have sum 153, and now we will have to check that 153 that we have as an input at the beginning of our code is equal to the sum which we derive from all this step. And then 6, return. Return whatever value your function demands, if it's a boolean or if it's a string. So now let's get into the two ways of finding number of digits. So for finding two ways, we have a number 153. Either we turn this number into a string, and why we are doing so? Because string has a length function. See, there is not necessarily only two ways. I am just telling you the two ways I popularly use. So after converting this number to string and having the length method on the string, we will have our length or the number of digits. Or there is a mathematical approach to it that the length or number of digits a number hold is equal to log of number base 10 plus 1. So this is mathematically derived and this is our by our code approach. The next step is take out each digit. So the next step we have already discussed in our previous problems. I'll link down the problem in the description or in the I button. You can go through it. So taking out digits, we have num modulus 10, and then we have num divided by 10. I have 153. So num modulus 10 is 3. Num divided by 10 is 15. Again, num modulus 10 is 5. Num divided by 10 is 1. 1, that is num modulus 10 is 1, and num divided by 10 is 0. As soon as we hit 0, we will terminate. Okay, so that's our next step. The third step is power. So as soon as I'll find my power, we have to sum it. So for finding the power, I have a math function math dot power d dot comma length, where d is the digit and length is the length of the number. So this is how we are going to find the power. And the next step is summing. We have to sum whatever conclusion we have in step 3. Fifth, we have to check, and then sixth, we have to return. So after concluding all these concepts, let's get into our code and see how we're going to code all these things. So now let's see our code. Here you can see that we have a 3-digit number, but for our sake, we are going to find the length of the number. So first of all, I have int length is equal to integer dot to string. I'm converting this integer n to string, and then I am calling length function on it. So now I have my length. The next thing, we have to have a sum variable, and then we have to copy n to a new variable. Why we are going to do so, I'll tell you in a minute. So we have double sum is equal to 0. Okay, so for now, let's take it int, and I'll tell you why I'm going to take double in the code. So now int enter is equal to n. Why I'm copying the value of n to enter? Because we have to manipulate n. We have to find modulus, we have to divide it again and again, and then I have to use this n to check whether this sum is equal to n or not. Therefore, in order to preserve this value of n, I am copying it to enter variable. I hope that's clear to you. Now enter is not equal to 0. This is a simple while loop for taking out the digits and adding it. So if you remember that for a single digit, what I have to do, I have to have enter modulus 10. Okay, then we have a digit here. Now what we have to do, we have to have a power of that digit up to like the length we calculated, and that value should be added to sum. So sum is equal to sum plus math dot power d is the digit comma length. If I have to save some lines of code here, what I can do is what we are doing here is we are just placing d in math.power function. Instead of d, we can replace it with enter modulus 10 itself. Okay, and then we don't have to handle a new variable d. I hope this statement is understood to you. Now what we will do, we will divide enter by 10. This statement is equivalent to enter is equal to enter divided by 10. So now after iterating this whole while loop, we have a sum, and that sum we have to check whether it's equal to our given number n. So after this while loop, let's check if sum is double equal to n. Then what we have to do, we have to return a true in string format because our function is returning a string. But I can also make our code a little bit concise here through removing this and directly returning a ternary operation, which will hold sum is double equal to n question mark true. If this condition is true, then the immediate variable or whatever value we have after question mark will be returned. Otherwise, after the colon, we will return the value false. Now let's focus on int sum. Whenever when I'll compile and run this, it will give an error. See, oh this is an oh sorry this is a different error. I just missed a semicolon here. Let's compile it again. So here is the error I'm talking about. Incompatible types possible lossy conversion from double to int. So this math.pow is returning a double value and our sum is int. Therefore, we have a lossy conversion because double is in terms of having values have higher range than integer. Therefore, I have to change this sum to double and then we have to run it. Okay, my first test case is passed. Let's submit it. Okay, so I have taken 0.14 time to run this code. Now, the second way from which we can calculate our length is the log one, the mathematical approach. I'll just comment this out. And we have math.log to the base 10 of number plus 1. This is my length. Let's compile and run it again. What's the error? Oh, is the lossy conversion error. So what I have to do, I have to typecast it in int. Again, it's running fine. So you can do it either by changing the data type of that variable or converting it into the int variable, int data type itself by typecasting. Submitting my code. So this time I have taken 0.11 and in the previous method I have taken 0.14. So there is 0.03 decrement, which is a good thing in case of time complexity. Now moving on to the bonus tip of this video. If you're having any kind of difficulty in calculating your time complexity or you want to check whether the time complexity you are calculating for your code is correct or not, you can just Google Bego calculator and it will calculate your code time complexity. These top two most websites that is mentioned like Bego calculate and timecomplexity.ai. These both are good. You can choose any one of them. So I'm just taking Bego calculation. And what we do, we paste our code that we have found, that we have coded, and it will calculate our time complexity. As you can see, the time complexity of is Armstrong method is O log n, and the space complexity is O order of 1. Sorry, not order of 1. And you can see the reasons why we have a log n or order of 1 complexity. So this is a tip. I hope you liked it. Thank you for watching this video. That's it for today. And मिलते हैं अगले वीडियो में. तब तक के लिए बाय बाय.